Welcome to the Leo AI and MI monthly webinar. I'll just remind you that a few months ago, we decided to merge between the monthly webinar of Leo AI and the community webinar of mechanical intelligence, or MI community, which is the first global AI community for and by mechanical engineers. This is the community for us mechanical engineers from around the world, from different backgrounds, from different languages, to come together, share what we learn during our work as the best use cases of AI, the best tools of AI, the best tricks and tips and even inner jokes to share with each other and to grow together, because we live in a very exciting, but also a little bit challenging times. We see our workflow changes. We see how AI is about to change mechanical engineering, and we don't want to stay behind. And we believe that there is no one company or one person that can possess all this information, as talented or smart that we think we are. So if you come across other tools that are not Leo AI, right? Or other tips, or you're using Leo AI in a way that we didn't think of, please take your insights and put them on the MI community pages. Chevy is going to write it down here. Just a link, which is mi.community, www.mi.community. Go there. You have all the links to Reddit, Facebook, LinkedIn. Share your thoughts and enrich one another. So in this opportunity, I will introduce myself and the agenda for today. I am Maor Farid. I'm the co-founder and CEO at Leo AI. And, I became a mechanical engineer when I started to dream about mechanical engineering. And it was the first time that I saw SolidWorks. And it was when I was in 10th grade. It's the first time that I saw it. It was by complete chance, by complete mistake, when I was passing along an empty classroom at my high school, and I saw a very weird software open on one of the laptops there. I looked around, saw that no one is looking, and at the moment that I touched the mouse, I was hooked. I knew that this is what I want to do in my career. 2 years later, I joined an elite academic program for mechanical engineers at the top school of my country. Completed my bachelor's, master's with honors, and then the PhD. And I was, totally hooked about mechanical engineering. I knew that this is my dream, right? And I started to work as a mechanical engineer in the defense industry. And I realized that I've done probably the worst mistake of my life going to study mechanical engineering. Because I remember, like it was yesterday, that I was spending, I think, something like 5 months just to find a couple of bolts and a couple of ball bearings. None of them was even a good fit. And I was puzzled because, like many of you, I went to study mechanical engineering because I wanted to innovate and create. And it was exactly the opposite. So I pivoted my career to AI. I was an AI researcher. Then, using Fulbright scholarship, I went to MIT to pursue my postdoctoral training at mechanical engineering department in mechanical engineering and AI. And then Moti and I, the most brilliant person that I know, and the Leo AI's CTO, we decided to start Leo AI. So share with you real quick what we're doing. At this opportunity, I'll just share with you who is going to be here with us today. We see Dr. Roland, the former CRO of Autodesk himself. And of course, I'll share the intro very soon. But Roland, super happy to see you. Thank you so much for joining us. And JJ Schwartz, one of our esteemed Leoers, one of our users that are going to share with you how he's using Leo to basically do everything that he was doing for 20 years, but just with less mistakes, higher quality, and with less of hours of tedious work. So we're Leo AI, and we're building the world's first AI made by and for mechanical engineers. And this is the agenda for today, right? When we're talking about AI for Machies, why now? It sounds maybe like a stupid question, but the answer is a little bit surprising. What the problem that we're solving? Why mechanical engineering is so broken? What really is broken? And I'm not talking about many clicks on SolidWorks, or SolidWorks is crashing or not, right? What's the solution? how we solve the problem at Leo AI. We'll talk a little bit about security because us as engineers, we know that the goal of our organizations is the data and IP. So it's something which is uncompromisable, and how Leo is basically providing a top tier enterprise grade security that all your data is secure, nothing is used to train AI models, secure as it could be, right? And what's next? And of course, during this time, we're going to interview Dr. Zeles and hear from JJ. So just a quick background of the history of mechanical engineering in general. If you're thinking about it, there are three eras in mechanical engineering, roughly speaking. And the pyramids and Apollo 11 were designed in a pretty similar way, and they were a part of the drafting era, where people were using pen and paper to describe what they want to design, what they're designing, right? Then when the computer was invented, CAD was inevitable. So AutoCAD was inevitable, SolidWorks was inevitable. When cloud was invented, on-chip was inevitable, and cloud-native CAD, right? Then AI, modern AI was invented, right? Deep learning technologies, neural networks. So AI-centric design era, the AICD era, was inevitable, and with it, Leo AI. And we're basically here. And this is our time, mechanical engineers, to decide if we are letting this train pass by or, go all in and hop on the train. So what really is the problem with mechanical engineering today? What is so broken? So this is a real screen recording of a mechanical engineer not designing a new Hummer vehicle, but just trying to add the simplest part of engineering, which is a bolt, just one bolt. And as you can see, maybe you sympathize with this. I guess you are if you've done, mechanical design. He's going to the CAD only when he knows exactly what bolt to put, where, and what's the diameter, etc. But all the rest of mechanical engineering is not CAD. Engineering is not CAD, and CAD is not engineering. 85% of the time is us engineers trying to figure out what exactly to do, what exactly bolt to choose. So he's going to Google, trying to find the formula for the Vermeer stress, putting it on his Excel spreadsheet, asking Joe at the end of the corridor, what's the safety factor that he needs to choose, or he's going to his PLM trying to find what's the right document that documents the safety factor and plugs it in to the Excel spreadsheet. He's going to his PLM trying to find the bolt when he finally has the diameter that he needs, going to TraceParts if it's not on his PLM, etc., etc. So in this example, it took 1 hour and 52 minutes. This is how tedious our work is. This is how not creative our work as mechanical engineers is. And it shouldn't be that way. We should focus on building, creating, right? We should make the decision what the bolt that we need in order to go to the really interesting question. So how do I make this design more carbon efficient? How I make it more comfortable for my customers, etc. So the problem is knowledge, right? In 2025, engineering knowledge is still siloed. So our knowledge as engineers is locked behind 4 different vaults. The vaults of the brains of the later career engineers, you know them, the engineers that in your organization since day one, only they know what coating to choose, what the thickness to choose in this and that housing. So this is the tribal knowledge. It's locked in the mountains of documents and CAD files that you designed during the decades of existence of your enterprise. Just imagine how many CAD files do you have in your PLM? How many documents are written in your PLM? So some of them are text files, some of them are CAD files. And in order to know several things, for example, what's the minimal thickness of the housing that I used in the 2023 model that I designed, I cannot read it anywhere in text. I need to open Onshape, right? And measure in the CAD assembly, right? What's the minimal thickness? A lot of the information is embedded in the CAD, not written in text. And the fourth vault is the global industry knowledge, the Bibles of engineering, the articles, the global ISO standards, DIN standards, etc. What's the problem? When I'm talking today with mechanical engineers, and you can resonate with it, agree or not, you are saying that you prefer Google over ChatGPT for some decisions. And this is the reason. The reason is that Google never lies. It shows you the answers that he has. But ChatGPT could lie. If you're asking, how many bolts do I need to use for this flange? He's going to tell you, oh, you need 8 bolts. And you're going to ask again, are you sure? And then he's going to tell you, oh, you're right, 12. You cannot build an airplane based on, oh, you're right. And this is the reason why. What you see here is one of many studies that explore what are the underlying data that ChatGPT is using. The main one is Reddit. And if you're thinking about it, if you know Reddit or not, Reddit is a social platform that the contributors, the users, are anonymous. And if you're thinking about it, this is exactly the opposite of how us humans built engineering for tens of thousands of years. Tens of thousands of years ago, people in Damascus were developing, swords and arrows and designed the metal and the metal properties based on knowledge that was going from father to son to father to son. Today, we're doing something similar. It's not father to son, but very smart engineers wrote standards that encapsulates this information, and we're based on this father to son in a professional way. It's exactly the opposite of Reddit. Reddit is anonymous people that you don't know their background. They're saying that you need to choose M5 bolt for spacecrafts, and ChatGPT is just serving you this wrong information. So ChatGPT doesn't know or doesn't respect high fidelity data for us mechanical engineers, or it's contaminated by unreliable data. It doesn't have your organization's context. So, for example, if you're working for HP and I'm working for NASA, both of us are looking for the same ball bearing, or for a ball bearing. You expect to get something simple from SKF. I expect to get something from, with space-grade titanium bearing. So everything is about the context. ChatGPT is not connected to your data, doesn't have the context. And most importantly, it does not understand CAD. It's a language model. And it understands language. It cannot read your CAD. So it's like talking to or getting insights from a blind mechanical engineer that cannot open your Onshape, your CAD tool or whatever, right? So if you're asking something about a shape or about the design, it literally cannot help you. And of course, your IP is exposed when you're using ChatGPT. So what we're doing at Leo, we are proud to say that we're developing the most boring AI for mechanical engineers possible, because we're focusing not on, sexy, fairy dust kind of AI that looks good on TikTok, but we want to make you engineers happy. We want to make us, our friends, more efficient, feel like heroes, and do less mistakes and build better products faster. And how we're doing so? We build the world's first AI that can understand CAD. It's not connected to Reddit. It's connected into 1 million Bibles of engineering, only high fidelity, most reliable standards, workbooks, guidelines, and articles. It's connected into your PLM. And it's like a super engineer that read all the wealth of knowledge of engineering and your tribal knowledge on your PLM and Windows directories and Confluence and whatever. And it's sitting on your shoulder. You can ask it any question that you would like in real time. And in this way, it saves about a third of your design mistakes based on the data that we collected from our customers. It has something like 26% accuracy. And it saves on average 5 hours a day per engineer. So just imagine how much time in tears it saves in design mistakes, and how much time it saves in going through bad reviews and doing those recalls, etc. And of course, everything is in enterprise grade security, so you can sleep quietly and know that your data is not used to train any AI model. It's not moving from your PLM and etc. So I would love to show you Leo in action, and then we'll go to hear from JJ how he's using Leo. So I'm going to share with you how our other customers are using it. So this is a real screen recording of one of our users using Leo. Imagine that you need to add, you're designing, let's say, a suspension system, right? And you need to add a spring. As you know, and at least from my experience, for me, it took 2 days just to find the right spring that I wanted, not including the documentations and meetings, etc. Right? So with Leo, it takes 2 minutes, not 2 days. So see what the guy is doing, what the user is doing. He's writing in free language what the problem in hand is. For example, I'm designing a suspension system. I need a spring with a compression of 100 millimeters and 20 kilograms of preload, etc., etc. Give me all the spring parameters in a table, and in order to fully define the spring. And Leo gives you first the plan, how he addresses the problem, so everything is explainable and transparent, right, and reasonable. And then he provides you with the answer. And this is what's important here. Every answer that Leo provides, it also includes references from the Bibles of engineering or from your organizational guidelines. So, for example, here, when it provides you with a formula, you can click on the source and Leo opens up the right page in the right book, saving you scrolling time. So immediately, every answer you could validate and feel confident with the decision that Leo did, right? Then you don't need even to open an Excel spreadsheet, right? Leo runs all the calculations for you. So it provides the formulas from your guidelines or from external guidelines, runs the calculation, provides a table with all the calculations. You can download it if you'd like, right? As an Excel spreadsheet. And then when you want to get the spring, you just tell Leo, hey, I want to buy the spring. And first, Leo goes to your previous designs. If it finds it there, it provides you with the spring. If not, it's going to one of the 120 million vendor parts that we have and provides you with the spring. As you can see, because Leo is not a language model like ChatGPT, it reads CAD. So even if the part is called part 3, right? It doesn't have on the metadata the constant of the spring, the length of the spring. Leo, because it understands CAD, it sees what's in it, and it can provide you with the spring that matches your needs, your requirements. And as you can see in a second, they're a good fit, unsurprisingly, right? Because it understands CAD and because it made the calculation for you. Of course, it asks also guiding questions if it's missing information. So the answers are very reliable as they could be. So what's the difference between ChatGPT and Leo? It's basically a more general question. What's the difference between vertical AI, I mean AI that made by and for specific profession, like AI for lawyers, AI for developers, and all the generic AI tools, right? So Leo's differentiation with respect to ChatGPT and others is context, workflow integration, security, and last but not least, CAD understanding. So context, it's integrated into your PLM. It knows your best practices and it answers based on your best practices, not just generic things that you read on the internet. It's connected into your workflow. So Leo is working alongside to your CAD, right? So you don't need to go to the browser and open it again. It's always there on your desktop as a desktop app. It has a top tier enterprise grade SOC 2 certified, blah, 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 security things that we are bored about, but your IT guys are thrilled about. So yeah, we have all the documentations needed. And again, this is the only one that understands CAD. So the only one that can serve mechanical engineers. So yeah, maybe with that said, I spoke enough. So this is a great opportunity to see how JJ is using Leo. So JJ, what's up, man? Are you here with us?
Hey, can everybody hear me? You hear me good?
Yeah, I hear you loud and clear, man. I'm so happy to see you here again with us. We're super thrilled on what you're building with Leo, and also just recently you started to educate the next generation of engineers to use Leo. You started
That's right.
to right. You started a new course training engineers to use Leo, right?
So yeah, that's correct. I was already teaching a course in CAD using Onshape, and we started to integrate AI into the process to show them how to get the engineering done. And
Amazing, man.
the feedback has been incredible. People are really impressed, and they're learning that how it helps mostly with the workflow. People seem to have this illusion that AI is going to come in and do all the work for them, and you're going to say, "Build me a robot," and it'll just do it. But that's not really where it is. They see how it's really, like you said, it's helping with the workflow, all the very tedious tasks that take up most of our time. So
Absolutely.
I'll talk briefly about myself. Let me also share my screen so I could show at the same time what we're doing. Here we go. I have Leo
Mm-hmm.
open over here. Briefly about myself, I worked in space and aerospace, and most recently, I'm a contributing author to the commercial lunar field guide. I encourage you all to check it out. I'll share the link in the description. So my background recently on my most recent project was on lunar mining. There I was a contributing author to this guidebook. So that's something I'd encourage everyone to check out. And on that backdrop, I decided to work on some projects related to lunar mining of oxygen. And one of the big challenges is heating the lunar regolith so that you could produce oxygen. So there's one of the things I tried to do was to design this lunar solar heat reflector that would concentrate the heat, as you can see here from this simulation, and focus all the beams onto the surface of the moon to heat the lunar regolith. So this was actually, it's very nostalgic that I bring up this project. It's one of the first projects I worked at with Leo. Leo was really the co-pilot on this. It helped me design the concept, helped me when I was doing the calculations for the optimal measurements and designs. And then ultimately I was able to make this, in the end, Leo helps in the background. And then finally, in Onshape, I would do the rest of the CAD work and do what you can see here is a solar rain simulation to fine tune the design. So this is one little aspect that I worked on. And the next project that I really like to focus on, where I really Leo took it to the next level in terms of heavy lifting, is this tank. One of the challenges of mining oxygen anywhere or mining any gas is that you're going to want to store that gas in a tank and then release it at a constant pressure. So this was a design concept that we came up with to store tank within a bladder, to store the gas that's produced in a bladder and then release it slowly at a constant pressure. So there's a lot of valves involved. Unfortunately, there's not enough time to get into the nitty gritty of everything here. If Maura would like, we can organize another webinar about that. What I'd really like to talk about is how Leo helped me with the finer details. All these components, all these swage lock valves, all of the connections. And that's what you see over here. I conducted my search to find all these valves. Now, in the past, I might go into McMaster's site, start searching through. This was as good as it got when I started doing the project. You would look through here, see what fit best, see based on the budget which worked best. I'd also search on TraceParts to get models and download the models and integrate it into my design. Now, once I come up with this concept, it's not just enough to simply run with this design on its own. I'll need to make different iterations. I'm going to have to make one for the lab. If I have a quarter inch, as you can see, a quarter inch piping here, we're going to have to do different tests to see if we want to work with a 1/4 inch or 1/2 inch. So let me go over to Leo, ask him to help me find different diameters, in this case, 3/4 of an inch. And I was actually looking for a 1/2 inch. And once, here's my 1/2 inch search. Sorry, I did a couple of searches. And over here, we're going to see the TraceParts integration being used in Leo. So in the past, I would have had to gone searching all over. And here I can just download the parts directly and then show you how I integrated it directly into my model. I've downloaded the part over here. And now I can just upload it. Oh, I've got the zip over here. Sorry. Here we go. Sorry, I pressed the wrong button. I'm importing it now into the Onshape model. And just like that, I went from doing a quick search, looking for the component with Leo, and very quickly integrating it into my model.
I think it's super inspiring, JJ. So usually, could you elaborate about like the previous ways that you used to, to choose components? So what are the, like usually you came across mistakes and how those, like, what were the consequences of those mistakes? What happens if like you choose or your
Okay, so what are the issues? Yeah, so one of the things I was talking about is also the different specs. Sometimes you can see here 0 to 10 liters per minute, the outlet being at 3 bars. So these are technical things. As you can see, Leo right away reminds you, helps you to, it's not just searching, anybody could just go into Google and say, give me a union key. And then, you go on and searching for it. When you search with Leo, as you can see, it's kind of pointing you in the right direction, reminding you which pressure, which connection style are you looking at. And that helps avoid mistakes, especially with less experienced engineers who might not be familiar with swage lock connections or snap connections or pneumatic connections. So that's one good example. The other example is, like I was saying, I want to compare. This is a concept that might be good for a space application, but anything before anything goes into space, it's going to need to be tested. So you're going to want to make a much less expensive model, and you're going to look for alternative parts. And that's the other place where Leo really helps out. You search for the components, and it's going to find you right here different components that you can compare with in real time. So it's having the information available, and also being pointed in the right direction, like you can see here. Don't forget the important details of the pressure rating and connection style.
Amazing, and thank you for sharing. And regarding time, like you think that like in the previous ways that you used to choose parts and now?
I did this in real time. You see, I already have the component here in my model that I downloaded, and I did that right here in front of you. So that was already much quicker. Even more important, there's two things. There's the time savings, which, to be honest, is sometimes hard to measure. But the thing that isn't hard to measure is the organization of your workflow. You have everything. Your chat is saved here. It evolves. This is, in the end, you're working with an AI assistant that's going to be pointing you in the right direction. If you make a typo, if you forgot a spec, Leo will remind you. So there's the organization that's very important, and that saves you time in itself because it gives you confidence, and it's keeping everything organized in this list. Like now I'm showing you this chat, but this chat is saved in your history.
Got it. Wonderful. And so what's the next project that you're gonna use Leo, JJ? Share with us. We're a little bit jealous.
You're a little bit jealous. Well,
now I want to be an engineer back again.
Well, to be honest, I'm using Leo right now. I've showed you this. The next thing, the project that I'm working with here is a simple thing. I'm asking Leo to help me design the struts here. That'll be and also the protection so that it'll work in space. And it would have to be a mechanism that could be kind of deployable. The whole idea, if I come back to this, this is a side project of mine. The idea is to have this be a folding thing that could easily fold up into a spacecraft. So that's what I'm working on now with Leo, to see how the different mechanisms involved there between the struts and how to fold everything up.
Super inspiring. JJ, thank you so much for sharing this experience with us. And once again, we were never be able to design Leo or to build Leo like it is today without people like you that are sharing, not only using Leo, but sharing their feedback, what they like, what they hate, what we could do better for you. And this is so valuable for us. So thank you so much, JJ. We really appreciate that.
I'd like to thank you guys. In the end, to be a 10x or whatever X engineer, and we have to have the best tools. So thank you for making the best tools. And that's why, I have a selfish interest in giving you guys the feedback so it makes you better and in turn makes us better. It's a wonderful feedback loop. So thank you very much.
This is the only way to go.
Exactly.
Thank you so much, JJ. I really appreciate that. And guys, I really encourage you to be like JJ and not only use Leo, but share with us what you like and what we could do better to make you better and more successful. So in this opportunity, I'm a little bit excited, I will admit, and later you will see why I'm excited and a little bit nervous. It's my great honor to welcome Dr. Roland Zeles, 27 years veteran of mechanical design software and a leader of the two most significant revolutions in technical design. He's a former CRO, which is Chief Revenue Officer, and SVP of worldwide sales at Autodesk. Dr. Zeles was responsible for driving global growth across industries. Today, he channels his passion into teaching, mentoring startups, advising private equity, and serving on boards, continuing to shape the future of engineering and innovation. Roland, it's a pleasure to have you with us.
Well, great to be here. I think, by the way, I saw on the chat there's a lot of questions. I don't know how you want to cover that.
Wow. So we have a team that does it in real time, and they're going to give us the filet of the questions for you.
Good. Okay. Perfect. So as Moa said, I was working, actually I had only 3 jobs in my life. I worked 10 months in a university. I think we'll talk about that for a quick. Then I moved to Huntsville, Alabama, worked for a company called Intergraph at that time, and stayed there for 8.5 years, and then joined Autodesk and was with Autodesk more than 29 years and retired on February 1st at the end of the fiscal year of last year. So finished the fiscal year and then started to enjoy freedom and do what I like and work with various companies. And so that's where I'm at the moment, on the board of some companies, teaching at 2 universities, and then working with startups and working also with PE firms.
And Roland, we were, during the last year, we're so grateful to learn from your, vast experience. But do you remember how it started?
Yeah, I think you shared this nice picture. So I think and I can talk a little bit about that. There was, the early days of ChatGPT. I think I was, playing around, and I was very fascinated, especially from one aspect of that, which is Codex, which is like automatically code generations. Or actually, I developed a game, and I was wondering why I think we're not making faster progress overall as a company. And while looking for tools, I think some of you have probably seen this, text to CAD tools, etc. I think Leo is talking about that in his chat. I found Leo, and I played around all the time with Leo and gave endless amount of demos internally and doing simple things sometimes, like, okay, create me a conveyor belt, build the steel infrastructure for that, getting the assembly instructions. And I was just fascinated how easy it was to interact with the tool and to build something, and constantly gave demos. And then, last year at AU, it's exactly 1 year ago, I was walking around the exhibition hall and just seeing like partners, talking to customers, etc. And then two guys. I think you probably were wondering what was going on because people took photos of me, etc. So I think they came close, and then I immediately knew who they are, and they were very surprised. And then I showed, I think, this picture where with on my Samsung Fold where I gave demos. I think you shared it on LinkedIn.
Just that people will believe what happened, because I still don't really.
So you can see, and this was my Samsung Fold. And I showed him, like, I constantly play around and gave him, like, showed him one of the demo examples I was using. So that's how we got to know. And then, I fell in love with Leo, and then we were discussing roadmap and, all the developments they're doing. And I just love to see the progress. So that's how we got to know each other. So actually a very, very nice thing. And I think it's like, I was already a user.
This was mind-blowing for us, really. The fact that you remembered my name and Moti's name, my partner, that was not there. It was, we felt like in a movie, and because it was a year ago, so much changed since then. The number of customers, I don't know, 50-fold or whatever, and revenue. But the fact that the CRO of Autodesk himself knew us by name, it's not only that you know the newest things, but it's a skill. It's a skill that I was not, I didn't meet so many people with this skill. I don't want to embarrass you too much, but it was a hell of a story for me.
I think it's for everybody. We'll talk about that. I think it's you constantly. I think, my mantra is like never stop learning. And I think you just constantly have to try out things and be just open-minded and approach things open-minded. And, some things you like, some things you don't like. But I think you will talk about AI because it's changing a lot. And, I have a long history in this industry, actually. As I mentioned, I worked 10 months at the university. And, it makes me old, so you can probably calculate how old I am. But I think at the university, this was when the first computer from IBM was launched, 1984.
Wow.
And by the way, at that time, a lot of other companies were born. I think Cisco, Dell, Adobe, Autodesk, PTC a little later, and then Synopsys a little later. But it was interesting how fast at that time a lot of companies moved with CAD models. So I think there was AutoCAD out, there was MicroStation out. As I said, PTC started 85. And there was also a German company called Caddy, a product called Caddy, CAD, and then a small d, small y. And my professor and dean was developing software for them. So I started to develop software for them as well, which was good. I think, made money because I didn't know how licensing worked. So I just said, like, for whatever price you sell my module, I want half of it, which turned out to be a good deal. So it was all my risk. I got no money. I only got money when they sold something. And why is it connected to what we discussed today? Mm-hmm. It's after 10 months, I quit and went to the US. It was a nightmare with the professors at that time. I think it was great with the students. I think they adopted like new tech, automation, etc. very, very fast. But the professors really struggled because, I give you two examples. One was cartography. At that time, you won't believe that, but there were specialists like, okay, what's the design of a map? Like, today everybody looks at Google Map and doesn't think about it, but they thought, okay, what is kind of the letters you use, how you write them down, etc. And then I showed him how to do that on Adobe. And I said, nobody needs to learn that anymore. And then like, how can I give the grade? And we need people to learn that. And anyway, so I had to change the course to force people to write letters. Same thing is on digital terrain models, like we just created it automatically, and then everybody was kind of plotting at that time, creating the same thing. And then the professor was like, how can I give a grade if everything looks the same? I'm like, look, that's just the future. In the future, you won't give a grade on this one. You give a grade how you plan a campaign, how you do. So anyway, so I got annoyed and I realized, okay, this is not for me. And then I moved on. I think what you should just think about today with the endless amount of computing power, and there's lots of debate, like, how good is AI? Where is it good? What is ethical AI, etc. I don't want to even think about quantum computing, where I think a lot of these discussions, I think, will start all over again. But I think it's what's similar today. A lot of people remain skeptic, and some of them afraid, and I think for good reasons, because they're worried. Will AI replace my job? And I think this is for everybody of us. I think we just should constantly think: is what we're doing, what is no longer valuable going forward? Like, searching in a catalog, I think as JJ showed us, I think you can really optimize your workflow. And where can AI become an assistant, a body, a bot, whatever you want to call it to yourself? Or what impossible things can you do now you weren't able to do before? As I said, I think everybody of you, whether you're a programmer, a developer or not, everybody can develop a tool or a game or something using tools like Codex or Replit. And then what can you move down market, I think, and democratize and automate? And I think you just don't be afraid of it, just adopt it. I think that's like the way I look at it. And this is also the comparison, I think, as you hear, for me, it's strange. I think I hear a lot of the same arguments I heard long time ago.
Yeah. And by the way, I had very similar experience, at the university, and we cannot really blame them because, like, this is part of the culture of universities, right? For the good and for the bad, like, they are all their profession. And when I was in academia, and of course you are in academia, you need to stand on the shoulders of giants and cite different articles, right? And stick to the methodology, to the stance. And for sometimes in history, the nonlinear leaps that you literally can't cite, you cannot reference, right? When CAD was invented, okay, so forget about the pen. You're going to use different tools. Now it's a keyboard, and people just don't let go. And but eventually, like the drafters disappeared, and I guess more people are going to disappear.
You still have some doing production drawings. I think that's probably now finally, I think we all were dreaming when, with 3D, I think you don't have a 2D drawing, but if you go to any workshop, I think there's production drawings and workshop drawings around like crazy. But I think it will go fast, in my opinion. And I think, there's lots of tools who do a lot of automation. I think I saw in the chat, somebody was asking about Fusion. I think they do, for instance, some of that, and everybody's experimenting around that. And I think it's the whole AI impact. If I look at it, I think there's three things. I think first of all, when you think about anything, forget ethical AI and all these things, I think up to mechanical CAD, I think there's more good than harm. Mm-hmm. If you agree with this statement, then I think you already can do a step further. And there's an interesting comparison. It wasn't AI at that time, chess computing. When the first the first time, I think it was IBM Blue or something, did beat Kasparov on chess. This was a big thing. And I think recently when Google did win against a master in playing Go, is on chess. And it was a bit strange at the beginning, but now I think all professionals use chess computers as sparring partner. And I think there's a similar thing to look at it. And I think, that's why a lot of people talk about assisting. So it's definitely more good than harm. The second thing is, and this is, I think, where you have to adopt knowledge and also think about what you want to do, but it's a productivity gainer. And good people become better. I think you saw JJ, I think he's faster, can do things better. So it's an amplifier for good people. And I think what's also helpful, and I don't know where they will land, but I believe it also makes the average better. So it becomes more an equalizer. So, and this is a lot of companies struggle with that because you have a bell curve of people, very good ones, mediocre and bad ones. So if the good ones become even better, it's great. If the mediocre ones become better, it's also good. Yes, you will probably save the not so good ones. Mm-hmm. The second thing, when I look at AI, I think it's, I use AAA as autonomous, it can be assistant, but it can also be annoying. And I don't know whether you played around with ChatGPT and you're in this endless loop of questions and like where you reach a point where you're like,
Yeah, yeah.
okay, delete this chat and start all over again. But then I think that's one, and I think there's a lot of this annoying. But I think you have to just make sure you think about it where, okay, what can be assisting? That's when I said earlier, it's a productivity and amplifier. And eventually, where can you use it for autonomous? I think a lot of the process, you talked about process. I think one thing you have to do as a company, make sure you standardize your process in a way, not too much to kill creativity, or innovation, but if you standardize it, you can digitize it. And the benefit now is with digitizing, I think you can automate it, and then I think you also can get a lot of AI help to actually help you potentially to build an autonomous engineer. I think companies dream about that. I talked about the production drawings. I believe within the next 12 to 24 months, you will see several releases of tools who can do autonomously create production drawings out of any model, and just plan for that. And then I think this will also drive productivity. I think that's what we currently need across the world in all our industry. So the
super fascinating
change of an engineer.
Yeah, and Roland, what makes you so unique in the horizon is the fact that you combine academia, engineering, but also very high management. So basically, you've seen so many angles of reality, and you do it only for 40 years, just 40 years, right? Just since you are 5, right? It is if I calculate correctly. So I will be fascinated to hear what you would say to engineering leaders, right? People that are engineering directors, VP of engineering, some of the bosses of the guys here on this conversation that are saying, it's going to take time to train the guys to work differently, to think differently. I'm not sure what's going to be. I know the ROI is going to be positive, but how much positive? Like, should I do it now? Maybe I will wait a few years. What's going to be your take on that?
I think it was good to have JJ here presenting. I think you have, that's why I said earlier, you have to start and you have to try. As I mentioned earlier, I think, just opening codecs and trying to develop software, and then you see, you learn each time with every mistake. And I think this has to do a little bit with your personality, but it's like, if it works, great, you succeed. If it fails, great, you learn something and you know what doesn't work. But I think the earlier you start, the earlier you will have a competitive advantage over everybody else. I think people talk about it, and too little people use it as an everyday tool. Because as I said earlier, I think I'm convinced the next 12 to 24 months, there's a lot of drawing automation happening. And some of the things we discussed and what you do on the automation, where you create facets into solids. And I think things develop much faster than in earlier times, and it's difficult to catch up. On the comment on training, what is the alternative to not invest in training? Not train your engineers, it doesn't work. So I would more take the concept, I don't know, recently you had this nice picture of this lead engineer I think was probably from Boeing on an airplane on the floor, where he was like,
oh yeah,
crawling over
lying over. Yeah.
This is prior to AutoCAD or like the CAD tools. But they had a concept of like a lead engineer, and they were like a hierarchy of engineers. And I think I would also think about AI in mechanical, look at the AI being your kind of support engineer, and what tasks you can give to somebody, like they can do for you, and suddenly you become you on your own become a team of 5, where you have 4 bots who you specialize on certain tasks and you use them. As JJ showed, if you have your chat, I think it just builds knowledge, and I think there's so many things you can do. If you don't start, you just fall behind. That's why.
I could not agree more, but I'm super biased. Oh, by the way, I forgot to say, for the guys that want to see Leo in action and how it could serve their organizations and teams, we wrote down here a link. Chevy will write it again. Just click on the link and you can book a meeting with us for your team, right? If you have more questions, because we will not be able to cover everyone's questions here. Feel free to click on the link and you will meet our team. We'd love to see you. So back to you, Roland. I'm sorry. So, we were super fortunate.
I have this chat open so I can see where people go. I think is that a lot of people were asking, okay, what other systems is being supported? I think that's...
Yeah, and this is why Eitan is answering them in real time. Thank you, Leo team. So, Roland, we were so lucky since the first time that we met at Autodesk University to learn from your feedback about Leo. So you were articulating so well, not only what you love about Leo, but what we can do better. So you pushed us forward and forward. And since the first meeting, you said that you saw Leo is doing things differently. This is why as you said, you love Leo. Yeah. So what do you think makes Leo different? What do you love about it?
I look at it. I think it's the integration as an assistant. If you want to make it very simple, I would say it's an assistant at the moment right away. And I think it will develop probably into an autonomous supporter you can use. Mechanical engineering has always been a craft. And I think, precision, creativity, and problem solving is there. And it still stays there. I don't believe with the AI, you can replace innovation or inventing new things, or like what smart people can do. I think I always look at it like when you look at if you let ChatGPT create you an answer, it's the average, it's a statistical model. So it's the average of what everybody else thinks, okay? And the same would happen. So how can you shine in this one? So I think this is your own creativity and your knowledge about being an engineer. I think that's definitely one thing where I think you didn't try to replace something. I think, and it's there where I think most people would agree today with AI. It's an assistant and it's a productivity gainer and eventually an equalizer. I think so. That's one thing, and then it doesn't break with the tradition of craft. Like it's kind of a continuation of the process, and it's like just goes in this history. I think when you talk earlier about the history, like the manual draftsman going to like an AutoCAD-like tool, then I remember when the 3D hype came. And everybody moved to 3D. And I think it progressed. And I think this is the next big thing is, in my opinion, is like having AI. It's an assistant and maybe it will take a little while until it will do more of that. So you're exactly helping on this journey of productivity and making things better. The other one, I think take a little prouder credit, even so I think you guys are so smart, is what I was pushing early on the PDM side integration, where they like, look, people are scared. And I think this was more from my experience. Different to in the AEC industry, everybody sends everything around with email and shares data because they build one prototype. Nobody worries too much about IP, okay? In the manufacturing industry, everybody is worried. I think nobody would willingly share the history tree of like the model. Everybody's like, no, this is mine, and it's so great. And that's why I think the integration into company tools and the PDM and the PLM is so important, that you're able to connect the two worlds, like the public AI, if you want, and the public web, but then also what is corporate IP. Will that ever break down? I don't know. But it's important, if you want to be successful today, you have to respond also to people who make decisions today, and they're worried. And I think that's the third thing I would say. I think keeping the craft, extending it, being an assistant, and then like also reacting to what the day-over-day problems then for the engineers.
Mm-hmm. And one of the most inspiring things that I was lucky to hear from you and to talk about is because you have 40 years of experience in the industry. You've seen everything and you've been there and done that. And you found that there is some kind of an imagination or any kind of similarity between the previous revolutions that you saw, that Autodesk did, and what maybe Leo AI is doing now. So could you elaborate about this? What do you think is the similarity, if any?
I think companies dream a lot of things. I think I would say the similarity is like the dreaming. I think we saw Onshape. I think others talked about Fusion. I think kind of cloud-based CAD. And one thing is have it in the cloud, and then the other one is it drives digitalization, automation, and AI. You went straight into that one, and then you had your mission, and I think immediately like, okay, integrate in everything which is around, which I think you have to and stick to a theme. I think we know us for a year. I don't know when exactly you started, when I got access to the early version of Leo. But I think it's you hold the course and you just improve and add. And I think that's probably one of the similarities a little bit when you compare to others. Like when we started talking about cloud and then people were laughing about it. And then I think, oh, okay. And then there's a use case here, there's a use case there. And then suddenly people realize it makes sense. So I think that's the same thing is here. I think it's like, as we saw today in the examples, I think it's the reuse, it's the knowledge, it's the parts. It's like how you can solve design problems. I think, unfortunately, JJ didn't show that part. But then integrating into existing systems. So I think I love the journey you have, and it's like step by step. That's also why I believe starting now is helpful, because you can grow with that and with a tool and also with the development in that area. And I don't think there's currently any tool which can do a lot of the work you do.
I really appreciate that. And, we have a lot of questions here on the chat, but because we're unfortunately we're approaching the end of the conversation. So we are mechanical engineers, and I'm thinking about the guys here on the call, mechanical engineers in leading companies or in smaller companies, enterprises, SMBs, whatever. We're all want to keep our jobs, want to stay mechanical engineers, but we don't want only to keep our jobs, want to be world-class in our job, right? We don't want to fall behind. So what's your piece of advice, for the end, for us mechanical engineers entering the AI era?
It's interesting how you asked the question about the job. I would say don't fear the cause. I think that's like it's just that's a problem. So I think it's more like think about the conversation you had, and when you think about like AI in your job, you just have to think about a conversation you have with somebody where you have a debate. How fast do you stop listening? Because in your brain, you prepare the answer. And unfortunately, as a human, we are not perfect set up in this one, because we are probably positive or negative, and we make this decision very early. So just make sure you spend the time to make a solid decision for yourself. And then the second one is really to have a distinctive voice. I think, where, just be clear as when I said like, assisting or annoying, where can it help? And small progress is progress all the time. And, we all love Kaizen, I think, from the past. So you're better today than yesterday, and tomorrow you're better than today. And that's a way I think I would look at it, as a kind of a minimum step. And then I think the curve goes up and is faster. And I would leave you with the last one. There's a great book, and I think it's still true. It's called Humans Are Underrated. It's several years old. It came up with all the automation. And I think it's just like, if you think about, if you want to solve a complex math problem and do it remote, it's very different. You need people in a room, like, you have debate and whiteboarding and everything you have to do. And human beings are very, very good in that, in innovation and disruptive bias. And that's why I think wouldn't be afraid. I would just think, okay, how can I use it? What can I do better, more innovative in using tools and innovation or if maybe it's even a disruptive new way of engineering. But I think you want to be at the forefront of that one because that's definitely the future.
I really appreciate that. And if we're thinking about it, just for Leo, we have more than 60,000 users right now. A lot of them they're cross industries and of course geos. So it probably means that if a engineer or a organization is not using any AI, not specifically Leo, whatever, right, is now behind his competitor in terms of tools. So, and leveraging AI or Microsoft Word or PowerPoint takes time. So if your competitor is already doing this, he's starting to learn it, you're going to see the results in a year. So I would really encourage, and I'm not talking, I know I'm biased, but I'm talking about any AI. If you're an engineer, a junior, senior, especially if you're a leader, I really encourage the guys here just to push them, to give them a license for app.gamma for presentations. Even for, I don't know, ChatGPT, it has problems with security, but any kind of solution, and start rolling to build, your skill set for the years to come.
Mm. And I think you can use Leo. I think you can trial it, and then you will see and do some small project, and you will see the difference. That's why I said, as I played around, I think just to see, and then you have your small success, and then you just keep going, and then I think Morty are more than happy to help you convincing your managers to spend the money for a license, and I think it's all the major things like SOC compliance or GDPR are fulfilled anyway, so there is no risk. But I know it's there's always a lot of discussion in large companies about risk.
Right, absolutely. And Roland, would love to keep talking as much as possible, but unfortunately we're out of time. And guys, especially in the Americas, are now in the working hours. They got to go to another meeting, I guess. But I cannot even thank you enough for your time and the value that we shared with us. Earlier career, later career engineers, really thank you for your time. And I really encourage you, Roland, to join us into the MI community, the mechanical intelligence community on Facebook, Reddit, LinkedIn. The people here have a lot of more questions. So this is a great way for you to communicate with them and the other guys here on the conversation to talk with people that are already there. John Hershtick is there, and John McElhaney, some of the greatest of all times, waiting for your questions. And hopefully if Roland will want to join, maybe he will too. So a great way to keep discussing. So Roland, thank you so much for your time, really, once again. And of course, we'll keep in touch. And for the other guys here on the call, again, if you'd like to see Leo in action and how it's going to can be applied to your team, assuming that you are a leading organization and you want to lead your market, please feel free to click on the link that we sent you. You're going to be asked a few questions just that will know you better, if you're using PLM or not, etc. Then you will be able to book a meeting in the next days, and our technical team is going to meet you. And this is going to be our way to meet you, know you better, to see how and if we can serve you and make you keep leading the market, and you to see how you can start your journey in the AI revolution for mechanical engineering. We're living in a super exciting times, and this is our turn to lead for the years to come. So guys, thank you so much for your time. Of course, the next webinars are going to be posted and being sent to you via email. You'll be able to register for free. And thank you so much. Keep leading, keep asking us questions, keep using Leo, and share the world how they should use AI. Thank you guys. See you next time.